taking the time out on a Friday evening, for some of you in the early morning. So glad that you could make it. Today in the second edition of Techtonix, which is a signature matrix tech talk around the technology challenges, problems, what we hear in the industry, we will cover the problem of cloud cost optimization. With us, we have Mr. Amiram Shachar. He is the founder and CEO of Spot.io, which is right now a part of NetApp. And Amiram is the VP and GM for the global product for NetApp. Along with him, we have Tomar. Tomar is the global head as well as the product head for Spot and NetApp. And we have, along with him, Levi Fredman. Levi is heading the strategy and he is primarily taking care of the Israeli market for the product. So welcome you all. We have Pranay from Matrix investment team. Pranay is a very well-known person in Indian startup ecosystem as well as the SaaS industry. We will have him in the panel today in the discussion, and good to have you, Pranay. Thank you for taking the time out. Last but not the least, with the partnership of Onnivation, this Techtonix was possible, and I'm glad to welcome Saket, the founder and CEO of Onnivation.
Thank you.
Good that we got you all together, and today we will have a lot of our portfolio founders, technology leaders, CTOs in this session. So over to you all. I will open the platform. Pranay, over to you.
Yeah, thanks, Deb, and thanks everyone on the Spot team for making it this evening. So I think we all know that cloud costs tend to blow up as the company grows, but these are also good problems to have because growth is good. But I think I personally saw this journey back at Freshworks, where we had severe problems around kind of first visibility into cloud cost, which departments, which products are spending how much money. After that, we were kind of looking at implementing some amount of controls and optimizations and many different ways to go about that. And then ultimately, we're kind of figuring out how do we keep cloud costs under control as we grow, right? Because you can't have exponential growth in the company and exponential growth in costs at the same time, and you need to find efficiencies somewhere. So would be good to hear from you as the experts, and want to keep this interactive. So everyone who's listening in, feel free to unmute yourselves and ask questions or drop it in the chat, and I'll pick it up from there. But the idea was to make this an interactive session to help you manage your cloud costs as you scale. And there's many sort of tactical pieces of advice that we can get from the Spot team over here, because we've seen this journey many times over. So with that, over to you, Levi and Tomar. And I guess if you have something to share, you can also throw slides up.
Yeah, sure. So first of all, Pranay, thank you very much for having us here. And Saket, thank you very much as well for making it happen. So welcome everyone. Thank you for the opportunity to talk to you today about our perspective on cloud automation for continuous optimization, what it means for us, what it means for our customers. We'll share a lot of perspective about how we look at cost optimization, cost management, cloud economics in general, while injecting a lot of stories from real life examples from our customers, from our partners, and of course show you some quick demo just to demonstrate some of the stuff that we're going to share. On top of that, feel free to chime in whenever it makes sense. It doesn't have to be a lecture here, and we will really appreciate to have a conversation. So you can use the chat to throw any question. You can go out of mute and ask anything. And of course, if you have any question at the end, we'll have enough time for Q&A once we're done. So in general, what we wanted to cover here is taking you through some slides that are talking about cloud economics at the very beginning, then about our approach to optimization, some of the challenges that companies are facing with, and real life examples. So let's kick it off. Tomar, if you can move to the next slide. And I think if you can use a present mode, it's going to be easier for the audience to see everything. So before we start drilling down into the challenges around cost management and cost reduction and optimization in the public cloud, let's make sure that we are setting the scene and set the stage and talk a little bit about cloud economics. So in this slide, I mean, we wanted to show you like the big picture. You know, organizations today are automatically leveraging public cloud and expanding and growing in the public cloud through migrations of existing applications, building new applications in the cloud, or every new startup is now building everything from scratch in the cloud. And when we think about cloud economics or about cloud costs, we sometimes think specifically about my monthly bill, how much I pay to AWS, how much I pay to GCP or Azure. But there is a lot coming to the cloud when we think about the bigger picture around economics. Cloud brought us a lot of other advantages that are not just cost reduction or cost efficiency. It gives us a lot of agility, developer productivity and tools, quicker time to market for developing and onboarding new applications and new products. Looking at the value of the brand, how my employees are even excited about using those kind of technologies. So all of that are bringing a major advantage to the public cloud providers, and definitely needs to be considered when we think about cloud economics. So if we even look at it one step further, and we're going to drill down into that later on in the presentation, we can really differentiate between the hard savings and the soft savings when we think about the economics in the cloud. So from one end, hard savings are everything about how do I reduce spend and optimize my use of compute, storage, networking, security environments? How do I avoid hardware and shifting to purchase software as an OpEx? How do I reduce operational cost, backup, DR processes? All of that are things that are hard savings that you can measure, that you can really quantify when you're thinking about cloud cost. But in the soft savings, there are many things that are sometimes difficult to quantify, but really important to the business. So how do I reuse services and applications across the board in a single architecture? How do I increase my developer productivity in order to make sure that my employees are happy with the technology, that I bring capabilities and features really fast to the market, and definitely improve my customer satisfaction and overall the brand reputation and the growth of the company. So once we are talking now, like later on during the session about how I optimize my environment and reduce cost, always think about all the other capabilities and advantages that you get from the cloud out of the box, and how you mix that into your mindset when you think about economics and cost savings. So with that, I want to hand it over for a second to Tomar to take us through the next topic.
Thank you very much, Levi. And as Levi mentioned, I see some new joiners here. Don't hesitate to intercept this conversation. We'd love to answer any questions as they come in. So really, when we think about cloud and one of the more common terms that started bubbling over the recent years is the world of FinOps. And working together with the FinOps Foundation, we've seen that really there's a few pillars or a few challenges that come up when you think about FinOps. And the FinOps Foundation also defined FinOps not just as the financial operation of the cloud, but rather as the financial development operations, right? So it's like the financial aspect of your R&D organization. And it's not just about Excel and managing spreadsheets. It's about interlinking cost management to your developers' experience and making it as seamless and as smooth as possible. And really, we've seen that some of the most challenging aspects are really getting your engineers to take action, making sure your business is adopting the right culture around spend, around cost management and governance, and understanding the trade-offs between speed and cost, and sometimes figuring out how do you optimize for both at the same time. Another one is dealing with shared costs. When you're spending everything with one major provider, being one of the cloud providers, instead of paying many different vendors, how do you make sure you know who's spending what across your departments and billing them accordingly so you can measure ROI in a more granular basis on your different teams? This gets even more complex when you think about microservices architecture. So not only that different departments can run in different resources, but rather they can all suddenly run within the same containerized environment and share microservices on the same hardware. Together with that, accurate forecasting is extremely challenging, right? So if you can't know who's spending what, it's really hard to focus when you can't correlate business growth to cloud cost. Making sure you're reducing waste or unused resources. We've seen examples of clusters running for months or even years where we came in to optimize them. Suddenly it didn't work, and the end customer realized it never worked. And they've actually spent hundreds of thousands of dollars running something that was actually idle, and no one was able to govern it properly. Making sure you get the right allocation in the right place, making sure you're aligning the finance and tech teams. The last thing you want is for the CFO to slow down R&D when engineering is such an expensive and strapped resources. And obviously container costs, as I mentioned, are even harder to discover. And then you will get some of like the SaaS challenges, but as you can see, they're very small compared to the rest of just governing the cloud itself. And the FinOps Foundation, and really what we're looking at mostly is really those worlds around focusing, engineering action, dealing with shared costs, visibility, and automation. And really what we see is that organizations over time are finding their cloud costs increasing and increasing, but not only that, the operational overhead that comes with it is doubling down as well. So you're not only spending more on your cloud infrastructure, but actually your engineers find themselves spending more time adapting themselves to the cloud. You end up hiring more headcount just to manage cloud. And this all falls into the same place. And those changes become even more complex when you're trying to do this manually. When you're not trying to adopt the tools, the automations, and what's out there in the market. And it's really important to remember that for probably most of you here, running an efficient cloud is a non-differentiating action for your business. It's probably not the core value that you offer your customers, but rather it's your operations in the back end. And the more time your teams can spend on delivering end customer value, while the overhead for operating the cloud is being lifted off their shoulders, the faster you can grow your business. And really what we want to see is that, as you move up, you're able to also leverage deeper and deeper discounts, while in reality, we see the teams find it more complex and harder to shave off every single percentage as time moves on. Really, in a nutshell, what we're finding is that teams have a lack of time and resources to handle the complexity of cloud costs, and the complexity is ever increasing. So every month that you're not handling it, it's going to be harder next month to tackle that, because hopefully all of your businesses are growing, and the challenges just keep mounting on each other. I want to take a quick pause here and talk about the pricing model that cloud compute is available in. I'm sure a lot of you are using infrastructure as a service, managed service providers of sorts. But what we also see very commonly is that about 70 to 80% of the cloud bill actually comes from the straight up compute that you're using. So in AWS, that would be EC2 costs, in Google, it would be compute engine, and in Azure, the VMs. But really, all of them offer three main pricing models. One is the on-demand one. You pay per second for what you use, kind of like the street price or the off-the-shelf pricing. You can scale it up and down whenever you need, so you're infinitely scalable and available, but the per unit cost is really expensive over time. Now, it's great when you're a smaller company and it's easy and you don't have to go buy hardware for $500,000, but rather you're just spending $15 a day. But that quickly starts going to thousands of dollars a day, and even tens of thousands over time. And that's where you start leveraging more sophisticated pricing models. So you buy commitment options. You'll get reserved instances and savings plans in AWS. You'll pay 1 to 3 years upfront or no upfront. You will commit to that period of time though. You can do partial upfront, no upfront, or all upfront, depending on how much discount you want to get and how much risk you're willing to take with them. But they're less flexible. And again, when we think about growing businesses, it's kind of an exercise you have to go back and do every week, because every week your footprint is probably a little bigger than it was last week. Or ideally, not probably. And it really adds more complexity, more overhead, and makes it harder to manage. And what you can get out of it is roughly 50% discount if you look at a mixed strategy, but anywhere from 30 to 60%. One of the slightly lesser known, but also gaining more and more traction over the years, options is the world of access capacity and spot instances. They're the cheapest option. You pay for what you use, just like on demand. You can scale it up and down on demand, and you have zero commitments. You can get anywhere from 60 to 90% discount, usually around 70 or 80. But with one main caveat that there's no SLA on these resources, and it's on you to manage any potential interruption that might happen there. Really, the ideal case for all of your environments is to figure out what's the optimal mix of those pricing models with as little as possible running on demand, so your unit economics are as good as they can be. And we talk about growing businesses, and we said in the beginning, it might be a good problem that your cloud bill is going up. And hopefully it is, but given that your unit economics stay the same or improve, right? So it's this way, once you optimize your unit economics, you can know that whenever the cloud bill goes up, it's good news because it means more traffic, more customers, more value to our end users, and not necessarily chaos that's going on and is getting out of control. Really want to think about FinOps as almost becoming a service in your environment. And ideally, you want to make sure you reduce the unit economics by up to 80%, but normally we'll see around 60, 70% reduction in the unit economics. We also want to reduce the operational burden. So the more we can automate, the more we can make happen seamlessly and repeatable across your organization, we'll remove the overhead attached to it. I've recently discussed with one of the major automobile manufacturers in the world, and they've mentioned that as they moved from their data center to the cloud, they gained a lot of flexibility benefits, but they found out that now all of their developers spend roughly a third of their development time on managing cloud infrastructure because they haven't made it repeatable, they haven't made it something that's clear to the entire organization. Across the several thousand developers they employ, that's hundreds of people that all they do really is operate cloud on average. And ideally, what we want to get to is reducing the infrastructure burden as much as possible, make it as simple as possible, as seamless as possible, as autonomous as possible for your internal consumers or your developers. And really, we want to make sure that application delivery is happening as fast as possible because that's why we're in the cloud to begin with. The way we achieve that is really by extending the world of CI/CD to CO. So I've mentioned in the beginning that FinOps is a behavior. So just like you're deploying code every day, or you're upgrading your systems maybe even several times a day, a week, a month, optimization shouldn't be an event. It shouldn't be something that you stop your development team for and say, hey, let's optimize now, because you always want to move forward. It rather should be a part of the flywheel of your organization that you're continuously optimizing. You want your systems to be as autonomous as possible, and make sure that they're constantly getting themselves improved. We as Spot are leading the charge here for the world of CloudOps, and which we really see that as three main pillars around DevOps, FinOps, and SecOps. Today's conversation is obviously focusing on the link between DevOps and FinOps. So how do you make your developers faster and more efficient in their development, but also more cost effective at the same time? At the Spot portfolio, we offer a variety of products around financials, so commitments management, visibility, cost showbacks, auto-scaling automation, lifecycle management for systems, container optimization, Spark workloads, continuous delivery systems, as well as end-user PCs running on Spot VMs. Now, from here, I want to start sharing a few case studies that we've had with customers and a few of their experiences there. And hopefully, some of you can think about how this could be relevant for your organization. Once again, feel free to stop me and ask any questions about what you might be encountering. The first story I want to tell is that of Ticketmaster. Ticketmaster is, I'm sure you all might have heard of them. They're a big ticketing platform across the world. There are over 250 unique products, over 1,400 people across product and R&D. And they've made a decision to start running everything on Kubernetes at some point in 2016-17. And really, they found out that there's a lot of complexity to Kubernetes and to infrastructure management underneath. And that's when we started working together. Now, we're talking about a Kubernetes platform that's managed by 3 people, supporting 1,400 people. Running over 1,000 nodes, tens of thousands of containers, and constantly growing over 100% year over year. So while Ticketmaster might be an older organization, the behavior of that infrastructure is very much that of a hyper-growth company. Now, What Ocean has enabled them to do is let the three managers of Kubernetes platform to completely focus on their developers' experience, while Ocean by Spot completely lifted all the overhead of managing the underlying infrastructure. Ocean essentially allows you to scale underlying VMs based on actual application demands in real time with no input required from your developers. And no overhead associated to your operators. So really they're able to completely focus on the applications layer. That's a team, the Global VP of Infrastructure and myself when we spoke at reInvent about that. And really that was the three main takeaways the team shared with the audience there. Adopting Kubernetes and Ocean has allowed the organization to be faster. So they're able to deploy versions more quickly without depending on operations team. Because their infrastructure is autonomous, it makes the right decision at the right time based on actual application demands, which it fetches from the containers themselves and the metadata around them. You will never need to communicate with your ops teams as you need to deploy new software. You're suddenly deploying a high memory system or you're deploying some machine learning models or anything like that. You don't need this, like that flow of ticketing and asking for high memory hardware and making sure it's available and it scales on time and justifying the budget. Rather, Ocean will see that metadata request in the cluster and immediately do all of that for you in the most cost-effective way possible. That meant that cost is so optimized that they're able to run anything that they run on Kubernetes with Ocean by Spot at 4 to 5 times the efficiency of anything else they've been able to do in the cloud. And that includes running reservations, auto-scaling groups, status applications. But the benefits of bean-packing servers more efficiently, as well as leveraging the right pricing models at the right time, completely outweighed anything else that they were able to achieve. And all of that was done while removing operations overhead and reducing complexity. And again, really important to emphasize the benefits of making your infrastructure as autonomous as possible to gain the benefits from all angles. Does anyone have any questions so far about how that might have happened? Is the audience here leveraging Kubernetes in any way? If anyone doesn't mind sharing.
Hey, Subhash here. Hey, Subhash here.
Hey, Subhash.
Yes, so we do Kubernetes for all of our deployment on the back end as well as on the front end. On front end, the interesting part is that we operate, we started with India, but now we are sort of soft preparing for the global launch. And with that, what we're doing is we have deployed a Kubernetes cluster on pretty much all of the regions in AWS, and not just AWS, pretty much all the cloud we could find out using your kind of with our own IP Anycast and BGP kind of stuff. And there, what the benefit that we have is we can push a simple code to our GitHub repo, and the code is built and deployed to all the clusters. And those clusters are individual clusters, not connected in any way to any of the other clusters. And the deployment happens across, I think, 35 clusters simultaneously. So that is what Kubernetes is helping us achieve, which was not really possible earlier.
Yeah, so actually that sounds like a really interesting use case. So one of the really cool things about Ocean is that it can integrate to your existing Kubernetes clusters, right? So if you're using EKS, AKS, GKE, KOps, KubeADM, KubeSpray, Ocean can simply connect to the existing clusters you have. And let's say you go live across the globe in 2 weeks from now, and suddenly 500 million people log into your platform. One of the really cool things about Ocean is that even when that happens, it will make sure you immediately scale up to support all that traffic and keep you as cost optimized as possible. If I take some of the examples, when Shelter in Place started in March 2020, we've seen some of our customers across video conferencing or mobile gaming, anything that really had to do with living online. Their traffic actually 5 to 10x overnight. And really, we kind of like messaged that customer like the following day. We were like, hey, is everything okay? And they're like, yeah, we actually did nothing. The traffic just came in. You scaled up everything. We're still at 90-something% utilization. We run almost 100% on spots, and we didn't have to lift a finger to do that. That's one of the really cool things about Ocean, and it standardizes your behavior across clouds. So you treat Ocean or your infrastructure auto-scaling the same in Google, in Azure, and in AWS. And your team doesn't have the overhead of learning infrastructure very differently in every cloud. Everything stays in your environment, by the way. We only access metadata around it, and you keep running everything inside your own cloud accounts. Subhash, does that make sense on how Ocean could still be valuable in such a global deployment?
Yes, because the cost of running these things is like kind of ballooning up, and from what we have earlier, and now we're trying to find out a way. But at the same time, the constant worry is that if we run something on, like, let's say, for example, Spot, for instance, and one of the constant worry that we hear from everyone pretty much we talk to is that the SL is not really great. I mean, you can have your instance taken at any time, and you don't really have much time at the time when the traffic is critical or some important processes running, that instance can be taken away. So how do we have the balance where, kind of we can still use a Spot or something like Ocean while still kind of maintaining the cost and performance balance that we're looking at?
Yeah, so actually Ticketmaster are a great example for that as well, right? So when they open a new tour for someone famous, let's say, I don't know, a Kanye or a Taylor Swift or something like that, they literally go from 100,000 people trying to buy tickets to the random stuff they sell to 10 million people and 50 million bots attacking their website to buy tickets for that big tour to try and resell them. And because Ocean handles auto-scaling so quickly and so efficiently, it's actually the solution to those type of spikes. And Ocean by default will deploy Spot instances across a variety of markets, maintaining high SLAs. So really, it never puts more than like 2 or 3% of your cluster at risk of getting reclaimed by AWS or the cloud provider. When that happens, Ocean automatically cordons and drains all of the nodes, moves all of the pods to different nodes, makes sure to spin up infrastructure in a different access capacity market, or fall back to on-demand to maintain your SLAs. And because of that, really, we see customers, I'll share Ticketmaster with their tens of millions of customers. The next one I wanted to share is Duolingo, over 300 million users, all running 100% on Spot. Another one is actually the world's largest digital bank, runs over 80% of itself on Spot instances with us. Over 50 million people accessing their bank, which is not something that you would be very patient if wouldn't work, right? So the idea is that we are the ones that help you manage the SLAs, manage the interruptions. It all happens autonomously with zero overhead from you. You simply plug into the clusters and we handle all of the stuff on the back end between you and the cloud provider.
All right. So from where I understand, we don't have to worry about the interruption signals and anything. That is entirely handled by Ocean. Is that correct?
Exactly.
Okay.
So obviously, if you're running like a single, a SQL database locked in a single pod,
of course not. Of course not. Mostly stateless. Of course not. Of course not. Mostly stateless transactions, right? Stateless your web service.
So, so for stateless web apps, this will plug and play immediately. Now, the other cool thing about Duolingo that I love about that story is I met them on a Monday morning. That same week on Wednesday, they pulled in their dev clusters. On Friday, they pulled in staging. On the following Monday, we closed the contract. And on that Wednesday, a week and 2 days later, they moved the entire production of Duolingo to our systems. They saved that same month $100,000. In those 8 days, we met like 3 times for an hour. That's the level of complexity we're talking about. It's really simple. It plugs and plays into your environments, and it will immediately deliver automations and cost savings.
Makes sense. Understood.
Tomar, one question, Sri here from SuperOps. Yeah. So you were talking about Ocean, right? So I think AWS offers EKS Fargate, right? So because it's completely serverless. So in terms of that, how do you compare that with the Fargate version of EKS? Because they don't have server, and the server farm is very big and it's completely serverless. Only thing is you need to handle it horizontally, and you don't have to worry about the vertical scaling of the nodes, right? Yep. So how different is that from Ocean? What it differs from what Ocean does?
Yeah, I think that's a really great and a very fair question. So I'll start with the fact that we released Ocean about 2 years prior to Fargate. So we've actually had a lot more experience working with customers to deliver value on top of that. Now, a few of the challenges that Fargate brings into the table is mainly the SLA around spots, right? So if you're trying to run Fargate on Spot instances, it will sooner or later get reclaimed, and the ability to recover from it is much harder. You would have to completely manage that by yourself, run a few lambdas, constantly measure the markets, see why the functions are failing, redeploy them on demand. So there's some complexity to it. Another thing that Ocean does, which I haven't spoke about here yet, is Ocean helps you right-size the actual microservices. So it's going to monitor them and make sure that they're making the right requests for resources. One of the challenges with Fargate is that it eliminates waste by not having nodes that have excess resources on them, but they force you to round your pod sizes to very specific numbers. So for example, you can't go like 3.75 vCPUs. You have to go for 4 vCPUs, right? So in those cases, there's always like the waste kind of happens somewhere, and they charge a small premium for the automation. We've seen that in head-to-head competition, Ocean is able to optimize ahead of Fargate by about 15–20% if we look at on-demand versus on-demand. Now, if we look at spot versus spot, also again, we'll optimize about 20% in the spots on Fargate, but spots on Fargate aren't actually serverless in a sense. You still have to wrap and manage around them to run with an SLA. You run your environment with an SLA and be able to do that reliably. And one of the last things is that Ocean is in a sense portable. Once you've learned how to use that, which takes minutes, you can do the same in AWS, in Azure, and in GCP. Well, Fargate gives you some sort of a lock into AWS, which might be fine, but that is there.
So how about one more thing which Fargate I personally see is that they don't support any of the external storage. Since most of our apps are stateless again, we don't need any of the external disk that we need to mount on to that Fargate or something. But what does that Ocean offers? Like, do you have an option of mounting an EBS or kind of a thing like an external disk to support to store anything that we wanted from an application perspective?
Yeah, so that's a great question. So yes, Ocean is actually completely aware to everything Kubernetes. So persistent volume claims, EBSs, affinities, anti-affinities, stains, tolerations, node labels, custom labels that we support, anything that Kubernetes releases, topology, spread constraints, and etc. Everything like that is immediately supported in Ocean. We keep track of the open source and then what AWS releases, which tends to be like a version behind. And we've been an official provider for KOps for a few years now, so we've been very close with that open source community.
Got it. Perfect. Makes sense. Yeah, makes sense. Okay.
Perfect. Any other questions about how we optimize Kubernetes specific environments? Okay. With that, I quickly want to mention like another cool case study we've had with Beeswax. Beeswax was recently acquired by Flywheel in the US. They were an edtech real-time bidding platform. And we met Beeswax when we were a very tiny company. Amiram met them back in the day, and they had like, 8 people working for them. And I think their yearly cloud bill already outpaced their like $15 million Series A because the product did blow up, but cash flows wise, it became really tough. And really, we were able to integrate with their team in like 3 days, reduce their cloud spend, and move their entire real-time bidding system to spot instances, reduce their bill by about 60% while removing overhead, managing all deployments, and delivering a lot of automations for them. And that really gave them like sort of a lifeline to breathe and keep growing, knowing that they're running an efficient business. So Beeswax have been a great partner for us over the years. Next, I want to talk about a slightly more complex implementation we've done with Wildlife Studios. So Wildlife Studios are a very big gaming company. They've recently went and raised their first round of financing, and I believe they raised like $60 million at like a $1.8 billion valuation. So they sold like 3% of the company or something at their first round of financing and became a unicorn because they've had some very successful games. And over 100 million active users, and really we've been running their entire Kubernetes platform for them. Whatever games that are able to withstand spots, we've been running those spots. But as you know, some game rooms might be taking 20, 30, 45 minutes. Even if we're able to predict an interruption 10, 20 minutes ahead of time, might not be the best gaming experience. So we've had them deliver a more mixed infrastructure of reservations and spots. And I think reservations really bring another level of complexity, right? So we see many companies go and do is, so, okay, we've adopted spots. That's already like a sophisticated thing. We see that people care for FinOps. And then they're like, okay, I have like a 70% baseline. Let me just go and buy this like one massive savings plan. But that doesn't give you a lot of flexibility to change things afterwards. And that does not make the optimal savings for you. And the way I like to think about it is just like you wouldn't take all of your money usually and invest it in a single stock. You also shouldn't take all of your commitment dollars to your cloud providers and put them in a single commitment model. And that's where Eco comes into the picture. But even without Eco, that's something I would highly recommend for your teams to look into, but rather building a portfolio of commitment plans between you and your cloud provider. When you have a baseline, even if your business is going to have a really rough year, you're probably not going to lose everything you do, right? So you're going to drop like a few tenths of percentage points at worst, hopefully not any of you, but reality is that these things can happen. So you can keep a baseline of even 3-year commitments. You can even do them some of them upfront. It makes sense to optimize savings that way. Beyond that, you're able to make combine the complexity of some savings plans, some convertible arrays, some standard arrays. But one of the really important things I would recommend for your team to maintain more flexibility is to buy some sellable commitments. So standard arrays or commitments you buy directly from the marketplace, you can sell forward. If your team decides to adopt more spots, if you decide to change the instance families you're using, if you're deciding to migrate to a new region, or I guess the Ticketmaster didn't have the best day when COVID started and not a single person would go to a live event for over a year. You want to make sure your business has that flexibility to offload commitments, to offload big spending dollars that you might have. You can definitely do that, in some ways by yourself, or hire a team of financial specialists that can govern that. We at Eco, with Eco, offer a solution that will completely automate that for you, run a full analysis of your environment, and make sure to get you the most optimal portfolio, as well as leverage our customer base and the fact we're managing several billions of dollars in spend to allow you to hedge risk better and increase coverage to a higher percentage point, knowing that we can offload commitments on your behalf to the rest of our customer base. Any questions about commitments management or commitment strategies with your cloud providers from anyone? Okay.
So I have one. So when you speak with the folks from AWS, right, or let's say Google, for example, they always say that spot is not good for kind of proxying use case. You should always go for reservation or mostly saving plans. What is your view on that? Is that the kind of what is your view on that? What do you think?
So I think that obviously that's kind of like not what they intended to do, right? They also don't want like everyone trying to run on spots production workloads, because then it's not excess capacity, it's the capacity itself. The reality is that, we have over 1,000 customers and about 98% of them run with us in production, as well as many other companies out there in the world. Mercado Libre, I think one of the largest e-commerce platforms in Latin America. So they're kind of like doubling down on Amazon. Not only that they compete with Amazon.com, they also run the entire platform on spot instances by themselves. So Amazon's not too happy about those types of things sometimes, but it is over $1 billion business for them, excess capacity. And while they intended it for a more batch type processing and high performance computing, it's definitely repurposable, and with the right architecture, especially if you think about containers, stateless applications in Kubernetes, I think they and the ephemeral compute kind of were a match made in heaven. And the reality is that you can definitely run production workloads on spot instances with the architecture you described that you have.
Understood. Thanks.
I think really one of the less important things that are really important to think through when you do cost management is the entire world of billing, usage, expense management, and etc. There's a few solutions out there. Really, I think very first step, make sure all of your resources are tagged, right? You can go to AWS Cost Explorer and filter based on that. That will be, if we're thinking about like an 80-20 thing, and you're just like, you want to start governing cost management, make sure everyone tags the resources, see who's spending what, who are the biggest culprits, who are the biggest spenders, can they optimize, do they need everything they do? Can they just run more efficiently? Can they shut off some resources? Highly recommend doing that even as a first step directly in AWS or with your cloud provider platforms. They have some free tools that will make it easier on you and can immediately deliver value. We offer that with Cloud Checker around idle resources, cost governance, visibility, reporting of all layers you'd be interested. But really, I think if you're just starting out adopting FinOps, you might just want to go about some of these things for yourself, getting more visibility, getting a better understanding of what's going on, and perhaps talk with us if you're interested in automations. I think lastly, really, where you want your infrastructure to get is here. As heterogeneous as possible, as many instance types, shapes, and sizes as possible, because it's not likely that all of your applications need the exact same hardware. So try and figure out where you're getting the best unit economics, either by application performance monitoring or just seeing resource utilizations, or understanding what your developers work with. You want to leverage the different pricing models. You don't want to run 100% on demand. You also don't want to run 100% on spot, probably. It's not going to make sense. And you also can't buy 100% arrays because everything is a moving target. So try and leverage as many of them as possible and get to a place where as least as possible is running on demand. And try to auto scale wherever you can. So try to not run idle resources, try to make sure that things react to traffic. That's probably one of the best things you can do. I think it was in one of the day in the life of a Netflix engineer that they've shared that they can do all the FinOps stuff they want, but if only their developers would write more efficient code that would scale based on what's actually going on in the business, that would probably be 10 times the savings of improving economics like that. So try and make sure you're on top of that, but obviously that comes with some engineering hours and complexity that might take some toll in itself. With that, I'd love to quickly share the customer journey that comes from the Spot platform. The process is very simple. Obviously, if we have a specific workload or a specific type of cluster we're interested in optimizing, we can kind of plug and play. It's a simple API call, Terraform script, CloudFormation, or any type of infrastructure as a code tool you might be interested in. But if not, we can kind of connect to both your master payer accounts and your sub workloads to understand what can be optimized how, right? So different methods of optimization are going to be a better fit for different workloads. And then figuring out how efficient is every account you're running. So it's not just about how many dollars it can save, but it's also about the efficiency percentage. And sometimes an account that might be 80% efficient could also be your biggest one. So that's still where most of the additional savings would be. So it's good to understand that balance, that an inefficient account, if it's a tiny dev environment that you spend $500 a month on, probably doesn't make sense to spend time making it more efficient. While if you have a semi-efficient account that you're spending $100,000 a month on, probably makes sense to make it fully efficient. So Cloud Analyzer will help you kind of see some of that. And obviously it offers some general cost analysis tool around spend, tags, filtering of all sorts, just to kind of get a better understanding of what you do. We offer that for free, by the way, if you want to start playing with that. And then if you're looking for more advanced capabilities, that's where Cloud Checker capabilities come in. And then we look at optimization. So optimization can really help you set like a target list of what you can do for your business. And you can decide if you want to leverage us or not to do that. But at least you can easily find your biggest culprits, your biggest spenders, and start thinking about how you'd like them to optimize. Again, Cloud Analyzer comes for free and is simply there for the analysis. So you'll be able to see that, hey, this EKS cluster running in EU Central 1, 65 instances is actually running on demand right now. EKS tends to be a good fit for spots. So if you would run it on spots, you would save $11,000 a month. If you want to get started, press the button here and we can help you do the migration. Once we found out everything that's fit for containers, we start looking at Elastic applications. So anything that's load balancer backed, anything that's in an auto scaling group today, anything with Beanstalk, and etc. And we can definitely plug and optimize those as well. And now that we've thought through everything that can run on excess capacity, we go to reservations and we try to get as high as the coverage as possible and see what is the potential savings from running a more sophisticated commitment portfolio around your environment and the benefits it can deliver over time. I think that's kind of the high level of our platform, some of our perspectives on cost management. If anyone has any more questions, I'm happy to dive deeper. This was, kind of touched on a few items, but I'm happy to dive into any of them and kind of share how we've seen customers tackle it with or without us.
Hey, Tomar, Sri here again. So I think in the initial slide, you were talking about the hard savings, right? About compute network and other stuff. So from our organizational perspective, we spend most on our networking part. That's where, it's really difficult to find out where actually, because let's say, for production type of instances or production kind of a VPC, we use NAT gateways as our, the internet provider for our private subnets. So in that case, we do see that there is a spike in our the NAT gateway usage or something. So on the networking side is something that we couldn't figure out what could be the exact outbound calls that is going on, or how much do we spend on those perspective? How can we optimize on those perspective is really, really a tough task for us. So in that case, what would you suggest or address to make sure even the networking can be controlled from an optimization perspective?
Yeah, so quick question about that. Are you seeing most of the network traffic costs coming from, inter-AZ conversations or your applications talking to each other, or kind of like egress traffic going out to the internet and back to you?
Yes, it's kind of most of egress traffic because we do have both AWS and GCP, and we have a couple of services that we do contact with GCP to publish. Basically, we use GCP PubSub for publishing our messages there and reading it from there. That's where we see that there is a spike with the networking traffic. So we wanted to leverage how this can help us to optimize those things as well, or is there any way that we can really optimize it out?
Yeah, so we're actually currently working on some capabilities, especially around containers, around deeper network visibility and understanding of traffic costs. So we'd be happy to kind of maybe have a conversation if you'd be interested after that. But I would say broadly, something I've seen in the past was one of those big ed tech firms I've mentioned that saw the crazy traffic increase when COVID started. About a year prior to that, they moved almost everything they've had into one big Kubernetes cluster from running on top of like a lot of different web apps. And kind of what happened is that the microservices started chatting between each other across the availability zones, all in the same cluster. And they were suddenly, the cluster helped them save like 400,000 by moving it to spots and, making it dynamic and all of that. They suddenly saw like a $300,000 increase in network costs because everything got too chatty and not running in the same place. Okay. What they ended up doing is trying to load balance as much as possible at the front and do as much as possible locally. So basically what that meant is that when a customer came in, they kind of like threw the request into a bubble that sits in a single availability zone, right? So there's just like one line of communication between the two, and then everything kind of happens in the same bubble afterwards. And I think that idea of running between VPCs or between cloud providers, I think it's really worth usually a closer look because of network traffic. We've seen that as a kind of like a repetitive problem that you're saying, hey, this thing can work so much better on the other side, and that will save me 20%. But then network gets so crazy that it actually adds 20% to the spend, doesn't save it, right? It's not a, it's probably a more common issue than you'd think, Sri. That you find the benefit of moving something between two places, but then the cost of moving it is becoming so wild that it's not always worth it. Exactly. We'd be happy to do a deeper dive with you if you're interested.
Sure. Okay, makes sense.
So, Tomar, one question from me actually. How do you, I think one thing we also addressed is how can teams get ahead of this and be more proactive, right? And I'm also thinking like, developers are building and deploying all the time. You want to give them freedom, but you want to give them guardrails within which they operate, right? So any thoughts, any advice on that?
Yeah, definitely. And I think that's kind of where a continuous optimization as a concept comes in, right? So you want to make this as interlinked to their development pipelines as possible. You want to burden them with it as little as possible. You want to automate in the back end, and sometimes that might just require several more DevOps engineers to make sure that all of the tools and the systems and the automations are in place. Sometimes that might mean onboarding a vendor of some sorts, but really what we've seen is that when companies think about it in day 0 or day 1, right? So before cost is a problem, but rather they plan for it, they kind of make sure that the infrastructure is ready, is autonomous, is continuously scaling. Then then they see a lot of value. One other concept I really like that I've actually worked on with one of the big media companies in the US is building with a spot-first mentality. So everything should be stateless, everything should be auto-scaling, everything should be able to withstand interruptions. Now, most modern development systems or stacks align to that, but making sure you're actually doing that as an organization is really important, because even if you don't, and I'm not talking about Spot by NetApp, I'm talking about like Spot as a VM concept, right? An interruptible hardware. So make sure all of your applications can withstand ephemerality. That automatically means that they're easier to bin pack, they're easier to auto scale, they're easier to optimize on, and they're actually easier to patch, manage, control, so you're gaining benefits from all angles, even if at first it's a bit hard. Culturally to your developers, you're going to reap the benefits of time efficiency and cost efficiency in no time, even regardless of our platform. So that would probably be my best recommendation. Make sure you're building as many ephemeral applications as you can and auto scale them. And that will not bother your developers with speed, that will actually add speed over time and will immediately make sure costs are better.
Got it. Thank you. Folks in the audience, any other questions or any other problem situations that you face that you would like to share? Yeah, I think we are good here. So actually, maybe I'll just ask one more question and then we can call it a day. But any tips, and I know there's no one from AWS in this room, so it's safe to ask this question, but any tips on how to negotiate with AWS?
So AWS are a tough one, right? Like I would say, generally once your spend surpasses $1 million a year, you can start negotiating EDPs. Right, so enterprise discount program, make sure you get one that's across the board. Now, if you have one specific source tree that might be interesting for you, you can sometimes kind of like give away, let's say they would give you 6% on everything. Maybe you can convince them to give you 4% on everything, but 20% on network cost. So like, this is really important for my business. If network is more cost efficient on AWS, I'll do as much of it on AWS. So kind of like obviously trying to play a bit that game of like, hey, like I have options out there, right? Like Oracle will give me 80%. Just not sure it's going to work, but maybe Alibaba will give me a nice discount as well. And then, the one thing I would avoid is really don't let them build a commitment strategy for you. Govern it. Make sure you're understanding what you're committing to. You can obviously understand the misaligned incentives. They'll try their best to help you. They really, the reps will really do a lot of work around Excel and trying to optimize that. But don't assume that every AWS salesperson knows how to optimize cloud infrastructure, right? At this point, they have over 10,000 of them. They're not all experts. Take everything with a small grain of salt and try to focus on where you spend that might be unique to your business. Might be easier to get a deeper discount on one specific type of spend than trying to get a deeper discount across the board, because they're becoming harder and harder with those as they become more and more clearly able to convince people to do everything in the cloud.
Got it. Perfect. So I think with that, I know we are almost near time, but last round of questions. Anyone else want to go?
I will ask.
Yeah.
So, Tomar, let's say if we want to use something like this, right? What would be the costing? How does the pricing model works out?
Yeah, so the pricing model is extremely simple. If we are able to take infrastructure, run it on Spot instances and save you money, we take a fee of the savings. If we fall back to on-demand to maintain SLAs, if you're just running everything on-demand for some reason, do not bill you for it. The entire bin packing and Tetris scaling we do between nodes and applications, we do not charge for those type of optimizations. After we've done all of that and we've taken nodes to start running on Spots, we take a fee of the saving from running them on Spots when they're running on them. per second, per usage, no commitments, no upfront payments, no surprises.
And what is the number that you want to share privately later, let's say if you have an onboarding call?
Well, the off-the-shelf pricing is 28%, but I'll say that it has never been a blocker for us to close a deal, and we'll work with you. And obviously, through Saket and Matrix partners, we'll probably be able to get you some more preferential pricing for this to make sense for you.
Understood. Makes sense. That's fine. And from what I can understand, just to confirm that we are able to run most of the on-demand workloads on the spot, right?
Mm-hmm.
Most of the stateless, I would say, stateless. Correct?
Yeah, exactly. So every stateless application that can be drained within a few minutes, or stop getting new connections and finish the current processing it's doing, can immediately be turned on to spots. It's really simple. And it's also very simple, by the way, to take a Kubernetes cluster and split the workloads on Ocean, right? So make sure some of them go to on-demand and don't get moved around, and some of them go to spots and kind of get juggled to be as optimized as possible. And with the on-demand, you'll still gain some benefits from the Tetris scaling, right? So your nodes are fully utilized. And again, we're not going to bill you for that piece.
And for India, or let's say Mumbai region being a small region for AWS, right? I have heard cases where they have capacity issues, let's say at times when you try to request a lot of spots instances. Have you seen something like that in India?
Yeah, great question. So in some of the smaller regions, it's challenging, but one of the cool things is that there's always excess capacity somewhere in the region. Ocean kind of out of the box supports all instance types, shapes, and sizes, and kind of will continuously look for excess capacity and then continuously try to fall back to on-demand in case it's not available. So if we go back to March 2020, literally had a few people calling me gloating. They're like, hey, did you lose your business? Because we just lost everything we ran on spots, and I'm sure you experienced the same. We're like, no, none of our customers experienced more than like 2% interruptions. And that's because of how we automatically distribute everything. And there's always excess capacity somewhere. Like if everyone's using all the C5s, they're probably not also using the M5s and the R5s and the F1s and the I3s and the H2B. And there's always some capacity somewhere, and it's still cheaper to run it on spot than falling back to on-demand, even if you're using like a fancier server, so to speak. Ocean handles all of it for you autonomously. So we've never seen that as an issue, even when shelter in place started.
And if
like Fridays or anything like that, we've been running customers 100% on spot there as well.
Understood. And if, let's say, for some reason spot is not available, you will still fall back on demand, correct?
Exactly. And even then we will try the entire data center, right? Like those, we'll make sure like SLAs will beat savings in our perspective anytime, and we'll do everything in our power to make sure your application stays up.
All right, sounds good. Thanks.
Thank you.
All right. So we are just heading in the end of the time. Thank you everyone for your valuable time and participation today. People who are here, if you are interested to know more about Spot or want to interact with the team, please drop a note to me. I will connect you to the respective people here. And Amiram, good to have you, but unfortunately your voice didn't support today. Yes, looking forward for another fruitful discussion. Tomar and Levi, thank you so much for presenting the whole concept of cloud cost optimization as well as Spot on that. And Saket, Pranay, thank you so much for making this happen. Good evening, everyone, and looking forward to our next edition of Techtonix soon. All right.
Thank you for joining us.
Thank you, Deblina. Thank you.
Thanks, everyone. Have a good night. Bye-bye.
Thank you very much.